Good afternoon, children. So today, first of all, we can discuss two numerical. The first question it is question number 7.2. In your textbook, Excel 1. So, what was that question means? In a hydrogen chloride molecule, the separation between the nuclei of the two atoms is about 1.27 angstrom. Find the approximate location of the center of mass of the molecule. Given that a chlorine atom is about 35.5 times as massive as the hydrogen atom and nearly all the mass of an atom is concentrated at its nucleus. Okay. So, in the previous class, we studied about how to locate the center of mass of a body which is placed along a straight line and also in a plane and then in a space into the terms of the different coordinates and also into the terms of position vector, and then as in the cases of an extended body into the terms of the formula integration. So here it is given that there is a hydrogen chloride molecule. So hydrogen chloride molecule means we know that its structure it is HCl. Okay, and then the distance of separation between these two atoms, that means the hydrogen and that of fluorine, it is given that 1.27 angstrom, I think, in the question. It is given that 1.27 angstrom. And what is meant by this angstrom? Angstrom is a unit which is used to represent the distance, the power. So 1 angstrom is actually equal to 10 raised to minus 10 meter. And here this hydrogen and that of chlorine molecule, it is get separated by a distance of 1.27 angstrom. And the mass of the chlorine atom, it is given that is 35.5 times massive as that of hydrogen atom. The mass of hydrogen atom, it is 1. So, what is the mass of chlorine atom? That is 35.5. So, here we can consider this is hydrogen atom at the origin. We can place hydrogen chloride molecule means the hydrogen and it is H at the origin. And chlorine atom Cl, its mass it is 1 and its mass it is 35.5 times as that of hydrogen, that means 35.5 itself. And here the x coordinate of the hydrogen chloride hydrogen molecule, it is H1, it is 0 because we assume that is placed at the origin. And then the chlorine atom, it is placed at 1.27 angstrom away from the hydrogen atom, means actually X2 is equal to how much? 1.27 angstrom itself. That means 1.27 into 10 raised to minus 10 meter. They asked to locate what? They asked to locate the center of mass of the hydrogen chloride molecule. So this is a linear molecule which is placed along the x-axis. So we studied that whenever there is a particle or that of a system which is placed along a straight line, here this is a system of two particles, its center of mass formula is two particle means it become m1 x1 plus m2 x2 divided by m1 plus m2. So here what is m1? m1 is 1. What is x1? It is 0 plus what is m2? m2 is 35.5. What is x2? x2 is 1.27 into 10 raised to minus 10. Divided by the total mass. Mass is how much? 1 plus 1 plus 35.5. So this comes as 0. Therefore it becomes 35.5 into 1.27 into 10 raised to minus 10 divided by 36.5. So, on solving, you will get, this is 35.5, this is 36.5, nearly equal values, as that whenever you are doing the for the exam purpose, if you can't use the calculator, means like that you can cut near value, or now you can use the calculator and check what is the final answer. You will get the answer as that is equal to 1.235 angstrom. So this is the way to apply that formula in order to calculate what, in order to locate the center of mass of a system of particle itself. Okay. So next is another one question, that is here there are three masses. The first one is 3 kg, second one is 4 kg, and the third one it is 5 kg, which is placed at the three corners of an equilateral triangle, and each side is having the length 1 meter. They asked to locate the center of mass of this system of particles. So here this is three masses, M1 3 kg, M2 4 kg, M3 5 kg, and that three masses are located at the corners of an equilateral triangle of side 1 meter, means each of this one it is gets separated by a distance of 1 meter, and it is in a plane. And they asked to locate what is the center of mass of this system of particles. So this is x-axis and this is y-axis. So in order to locate the position of center of mass of this system of particle, you people wanted to calculate how many coordinates for that center of mass. Two coordinates. One is x center of mass and the other one it is y center of mass, because it is a plane. In the previous case that was along a straight line, therefore only x coordinate. But here it is in a plane, therefore you want to calculate the center of mass, means that is actually the center of mass x coordinate and center of mass y coordinate, you want to calculate it. Therefore, first we people want to check which are the coordinates of this one. So here this mass M1, it is at the origin. Suppose we are considering this is 0, 0. That is x1, and that of y1 is 0, 0 position. And here this is M2 mass, therefore x2, y2. How much it is x2? This is x coordinate. X is how much distance? 1 meter. And what is y coordinate? Y coordinate is 0. And this is our third particle. So how much is x distance? This particle M3 from the x-axis, that is this much distance away. How much is that distance? If this is 1 meter, this is half of that, that means this x coordinate is 0.5. What about y coordinate? This is x3. What is y3? Y3 means this distance. This is 1 meter. X coordinate means half of this. This total distance it is 1 meter. Therefore half of this one means this is 0.5 actually. That is x coordinate is 0.5. What is y coordinate? Y coordinate is actually this much distance. That means this one. What is that y coordinate actually? In order to find that y coordinate, how much is this? This is 0.5. How much is this? This is 1 meter. They asked to find what is this, y3. So first of all we want to find what is y3. So in order to find y3, x3 this much distance, that is 0.5. And then y3 they asked to find. Therefore in order to find y3 you can consider this triangle A, B, C. So first you find y3. y3 is from triangle ABC. What is this distance? BC. So we know that this AB square is equal to this one, AC square plus BC square. So what is BC square? BC square is equal to AB square minus AC square. So what is AB square? AB is how much? AB is 1 square, minus AC square. AC means half, 0.5, that is 1 by 2 the square. So it becomes 1 minus 1 by 4. Therefore it is 4 minus 1 by 4, that is 3 by 4. This is ABC square actually. So what is BC? BC means that is root of 3 by 4, that is actually root 3 by 2. So how much is Y3? Y3 is root 3 by 2. So now we know what is X1, what is Y1, what is X2, what is Y2, what is X3 and what is Y3. Then first you can calculate what is X center of mass. X center of mass means M1 X1 plus M2 X2 plus M3 X3 divided by M1 plus M2 plus M3. So M1 mass is 3 into X1 means it is 0 position plus M2 is 4 kg into X2 means that is 1 meter plus M3 means 5 into half, that means 5 by 2, 1 by 2 divided by M1 plus M2 plus M3. How much is M1 plus M2 plus M3? 4 plus 5, 9, 9 plus 3, 12. Therefore it is 4 plus 5 by 2 divided by 12. That is 9 by 2 into 12. That is out of 3, it is 3 times, it is 4 times, 3 by 8. Alright. Okay. So you can solve it. Then similarly you can find this is X center of mass, Y center of mass. What is Y center of mass formula? Y center of mass means M1 Y1 plus M2 Y2 plus M3 Y3 divided by M1 plus M2 plus M3. How much is M1? M1 is 3, Y1 is 0 plus M2 is 4 into Y2 it is 0 plus M3 Y3, that is 5 into root 3 by 2 divided by 12. Therefore it becomes 5 root 3 divided by 12 root 12 into 2. So it will come as 0.36 meter. So what is the position of center of mass? Our center of mass means it has both coordinate, x coordinate and y coordinate. Y coordinate it is 5 root 3 by 24. It will come as 0.36, and in the previous case on solving that final answer you will get that is 0.52. Therefore this is the position of center of mass. This is the position of our center of mass itself. That means both coordinate, x coordinate and that of y coordinate. So I discussed two problems. One is from exercise and this one is an additional question. And related with this second question, I am going to give two homework. question number 7.1 from exercise. And next is example 7.1. As a homework, you must solve it. Okay? So, next we are going to discuss about the motion of center of mass of a system of particle itself. So, in the previous class, we studied that whenever we are considering a rigid body or that of a system of particles, in order to describe its translatory motion, whenever a rigid body or that of a system of particles we are considering, when that is in motion, there will be the presence of two types of motion at a time. One is its translation motion and the other one it is the rotational motion. So whenever we want to describe the translatory motion, that means a straight line motion of an object, as in the cases of a rigid body, that means a system of particles, we are considering the center of mass of that system, or we are studying about the motion of that system by considering its center of mass. And we know that the center of mass of a system means that is a point where the whole mass of that system, it is supposed to be get concentrated itself. And whenever while discussing that one, we found the expression for the R center of mass of that system of particle means that is equal to sigma mi divided by capital M. For a system of particle with I number of particles are there, and if n number of particles is there means this sigma, it is varying from 1 to n, and this capital M stands for the total mass of that system, and this number will vary for individual particles. So whenever we are taking this one to here, you can write m into r is equal to sigma I is equal to 1 to n mi/rn, and this I is varying from 1 to n itself. So whenever we are writing this one for a system of n particles, you can write this one as m1 r1 when I equal to 1, when I equal to 2 this is m2 r2, when I equal to 3 that is m3 r3 plus etc. of mn rn divided by the total mass and that we took here. And then if you are differentiating both sides with respect to time, what is meant by differentiating with respect to time means we are finding its derivative with respect to time itself. So m will not vary with respect to time, but the position of that center of mass may vary. Therefore r is a variable there. So you can find the differentiation of that r center of mass, and how can you write it? That is d by dt is the operator which is used to find the differential. So it becomes d by dt of r. So whenever you are differentiating on the left side, you have to do the same process on the right side also. So here you want to find the d by dt of this whole function, d by dt of m1 r1 plus m2 r2 plus etc. of mn rn. And whenever you are finding the differentiation, for each term you want to find the differentiation. So the each term differentiation means mass is not varying, therefore it becomes m1 dr1 by dt plus m2 dr2 by dt plus etc. of mn drn divided by dt. So how much this will be? This one become m1. What is dr by dt? Where r stands for position, time rate of change of position. What is time rate of change of position? dr by dt, time rate of change of position is actually velocity, position vector. Time rate of change of position vector is what? That is actually velocity. Position means displacement. Position vector means displacement actually. Position vector means it is giving the measurement of displacement of that body. Therefore, dr1 by dt means that is velocity of that first particle. So, when a system, that means a system of particle or that of a rigid body, it is in motion, its velocity or its motion you can describe it as m. M stands for the total mass of that system. And dr by dt stands for that is the velocity of that center of mass. Here r stands for the position vector of center of mass. Therefore, dr by dt stands for the the velocity of that center of mass itself. Therefore, you can write that is mv. And what is dr1 by dt? dr1 by dt stands for the velocity of that first particle, therefore it becomes m1v1. Plus you can write for the second one as m2 v2 plus m3 v3 plus etc. of mn rn itself. Sorry, mn vn itself. So the velocity of that center of mass into velocity of that center of mass is actually equal to the mass and velocity of what? Mass and velocity of that individual particle. So from here, what is the velocity of center of mass formula? V means that is m1 v1 plus m2 v2 plus etc. of mn vn divided by capital M. So this is actually the formula to find the velocity of center of mass of a system of particle itself. Understood? So the center of mass, in order to describe the motion of that whole system, you just want to locate on what? You just want to locate on the center of mass of that system, and then you can describe its motion itself. So from here, m into v is equal to m1 v1 plus m2 v2 plus m3 v3 plus etc. of mn vn. What is actually m into v? Mass into velocity of a system of particles stands for its momentum, linear momentum itself. So from here, m stands for the total mass of the system and v stands for the velocity of that center of mass, means actually that is the momentum of that system. And the momentum of that system P means m1 v1, that is p1 plus p2 plus p3 plus etc. of pn. That is the linear momentum of a system, n number of particles, is actually equivalent to what? That is equivalent to the total linear momentum of that system is equivalent to the linear momentum of, in order to describe that system, you can just consider the momentum of its center of mass also. Okay, that you can keep it there. We can come into that point later. So here mv, mass into velocity. Then here we are calculating what is the velocity of that system of particle. So in that same way, if you are differentiating on this formula, what you will get? M into d by dt of v, that become equal to m1 dv1 divided by dt plus m2 dv2 divided by dt plus etc. for the nth one, it become mn dvn divided by dt. What is the meaning of this one? What it means that? That means that the time rate of change of velocity. What is time rate of change of velocity? Time rate of change of velocity of a particle stands for what? Time rate of change of velocity of a particle, dv by dt, stands for its acceleration. Therefore, here you can write the mass of that whole system into the acceleration of that center of mass, ma. A stands for acceleration, that is equal to m1 a1 plus m2 a2 plus m3 a3 plus etc. of mn r. So ma, from here you can write the expression for acceleration of the system of particle, means that a is equal to this formula divided by the total mass of that system. That's about the acceleration of center of mass in order to describe the motion of that center of mass of a rigid body. And from here, if you are taking this a here, ma, what is mass into acceleration? As per Newton's law of motion, we know that mass into acceleration of a particle means that is force. So this is actually the total force exerted on that center of mass of a system itself. So the total force on a system of center of mass, this one A stands for the center of mass acceleration, this V, capital B, stands for the velocity of the center of mass, and capital R stands for the position vector of that center of mass. Therefore, this F is equal to F1 plus F2 plus F3 plus etc. of Fn, which means that the force on that center of mass is actually equal to the force experienced by the n number of particles present in a system itself. If we are considering a rigid body or that of a system of particles, that means there are the presence of n number of particles are there, and each of these particles is experiencing a force because of its interaction, that is internal force. And at the same time, if this system it is under the influence of any other external force, there is the presence of an external force on that system also. But this force F means that is only because of the external force. We are neglecting this internal force. Why? Because of means each of these particles in a system is under mutual interaction. Therefore, for a force F1 on one particle, it has an equal and opposite force as per Newton's law. Therefore, total internal force is cancelled. So, here this force on this center of mass means this MA stands for what? Acceleration of that center of mass, and that acceleration is causing a force on that body, means that force is pure external. There is no presence of internal force on that system. Internal force is get cancelled. So while describing the motion of the center of mass of a system, we just want to consider the force, that means the external force which is acting on that center of mass of position. No need to be bothered about which are the internal forces acting in that system. That means no need to bother about the nature of that system. We just want to consider the external force on acting on that system, or that means on the center of mass of that system. Therefore, in order to study about the rotational or that of the translational motion of a rigid body or that of a system of n number of particles, no need to be bothered about which are the internal forces acting in that system. We just want to focus on the external force applied on the center of mass, that means just the same as that of a point mass as we studied in our previous case itself. So, the description about that body become easy. No need to be bothered about n number of particles, just want to locate on the center of mass and what is the total external force acting on that center of mass is needed to consider. And one of the best example to understand the center of mass motion, we just want to consider the external force is actually the projectile motion. So, whenever you people studied about the projectile, you people know that the projectile which is fired from the horizontal line with an angle, a certain angle theta, that will follow a parabolic path. So, suppose a projectile it is fired from here. Suppose that is a bomb or something which is fired. If it is following a parabolic path from the air, suppose this projectile means it is made up of a system of particles, therefore it has a center of mass. So while studying about the motion of that body, we just want to consider the movement of its center of mass. No need to consider about the number of particles present in that system of projectile. But suppose it is get exploded from the air. The fragments will move in different directions. And that explosion of that projectile from the air, that may causes due to which force? Internal force. And these fragments are moving in different direction. But what about the center of mass of that system? That center of mass of that system or its motion means center of mass of the system will continue the same path. Why? Because means that center of mass, whenever you are locating, you just want to consider the external force acting on that system, and external force acting on that system is only gravity. It is moving only under the action of gravity. The explosion, it comes there, that is because of the internal force. But whenever we are studying about the motion of a center of mass, no need to be bothered about the internal force, the external force only need to consider. Therefore the gravity, therefore we can say that when something it is happening like that, the center of mass, the mass of that system is following the same path itself. Or in order to study that motion, we can say that will follow, the center of mass will follow a parabolic path like this. So that's about the description of what? The motion of center of mass. So okay, thank you. So today's class that much. Today's notes you can prepare it by reading the text. The notes I won't send it today. Later only I will send. So you should try to complete the notes and do homework I given and do that one also. Okay, thank you.